Okay, 11.4. We were talking about inscribed angles today, and by the end of the video, you should be able to find the measure of an inscribed angle. So, some of you are probably wondering, what is an inscribed angle? So far, we've talked about central angles, so we should know what that is. A central angle, kind of like how its name sounds, comes from the center of a circle. So it's formed by two radii. And let's say this central angle is 100 degrees. Well, that means that the measure of this arc that it intercepts is also 100 degrees. An inscribed angle is not in the center. An inscribed angle, and I would draw this on your paper right by inscribed angle. An inscribed angle, the vertex is not in the center. The vertex is on the circle. So vertex is on the circle, not at the center. That's important. And it's also important that you notice that it's formed by two chords. So this line will always touch the other part of the circle, another part of the circle. So let's say this arc is still 100 degrees. Okay. This part of the arc where these two chords meet, that's called the intercepted arc. So we could define the intercepted arc as part of the circle. Let's see, part of the circle where inscribed angle cuts off, meets the circle. So, for example, here's where the inscribed angle ends. Here's where the inscribed angle ends. So all of the space in between those two chords, that's called the intercepted arc, excuse me. So this is the intercepted arc, and let's say I tell you that this is 100 degrees. Well, if this was the central angle, this angle would also be 100 degrees, but it's not a central angle. It's on the vertex. It's an inscribed angle. So what that means is it's going to be exactly half of it. So something I would write is that it's always half the intercepted arc. Super important, and that's called the inscribed angle theorem. Again, the angle is always half of the arc. So in your own words, what I would say is that the arc is always bigger and that the inscribed angle is always smaller. So you're either going to be multiplying by 2 or dividing by 2 in this case. Okay, so for example, find measure of angle PRU. PRU is this angle right here. And if you notice, it's an inscribed angle because the vertex is on the circle. And if you look at where the arc that it intercepts, these chords cut off this part of the circle. And I know that this arc is 118 degrees. This is bigger than this one. The angle is smaller. So that means I need to divide by 2. So 118 divided by 2 is, 118 divided by 2 is 59 degrees. 59 degrees. Notice my answer is in degrees. For number 2, this is supposed to be an arc. Find measure of arc SP. For this one, remember, this is a minor arc because they're only giving us 2 letters. So that means we want to find the arc that's the shortest distance from S to P. So they want to know what this one is. All right, well, if you look, it's being cut off at P, and that's this chord, and it's being cut off at S, that's this chord. So if you see where those two chords meet, that's inscribed angle PRS. And an arc is always bigger. So that means I take this angle and I multiply it by 2, and that's going to be 54 degrees. So your answer is 54 degrees. Okay. So you're going to do number 3 and number 4, and I will check that one when you get tomorrow in class. And then you can answer this one. Which one is always bigger, the inscribed angle or the intercepted arc? So that's the first thing we're going to do. Okay. Second thing, congruent arcs and inscribed angles. So congruent arcs, what that word means, congruent means the same. So congruent arcs means 2 arcs that have the same measure. And what does that have to do with inscribed angle? If the inscribed angles intercept the same arc, then the measures, or you can say that then the inscribed angles are congruent. So what that means is, number 5 says find measure of angle L. LJM. Okay, LJM. I want to figure out what this angle is. And if you look at the information I give you, LJM cuts off this arc. And if you look at this other one, LKM also cuts off this arc. They both are intercepting the same arc. Since they intercept the same arc, that means that they have to be congruent. So all you're going to do is say 5b minus 7 equals the 3b and solve. So I would subtract the 3b, and you get 2b minus 7 equals 0, because 3b minus 3b is 0. Add 7, and I'd get 2b equals 7, and b equals 3.5. And we're not done, because it wants to find the angle. Since they're congruent, it really doesn't matter which one you plug it into. I'm going to plug it into this one because I think it's easier. So 3 times 3.5 will give me the answer, and that is 10.5. So your answer is 10.5 degrees, since we're talking about an angle. Okay, you're going to do I'll do number 6 with you again. Okay, so again, find measure of angle EDF. EDF. If you notice, it's cutting off arc EF. And if you look at the other information they give you, what else is being cut off by EF? This angle right here. So since they cut off the same arc, they're congruent. So all you have to say is 2x plus 3 equals 75 minus 2x, and then solve for x, and then plug it in to angle EDF. Okay, that's all you have to do for when the congruent arcs and we have inscribed angles. Okay, example number 3. Triangles inscribed within a circle. What that means is, inscribed means inside, basically. So whenever you have a triangle inside a circle, and notice that this is a diameter, that means that this angle will always be a right angle, or that this will be the hypotenuse of the circle. Okay, so in my own words, what I would say is, if a triangle side is also the diameter of a circle, then it's across from 90 degrees. Or you could say it's the hypotenuse. All right? So that's really important. So for number 7, if you notice, this is a diameter because this is the center of the circle and this chord goes through it. So this is a diameter. So what does that mean about the angle across from it? That means that this has to be 90 degrees. So to solve for A, you go 5b plus 20 equals 90 and subtract. So 5a equals 70 and divide, and I believe you get A equals 14. All right, so you're going to do number 8 that same way. Okay, so that's important. The important thing to know about triangles that are within a circle and have one side as a diameter. Okay, the last thing we're going to talk about are quadrilaterals inscribed within circles. So again, quadrilaterals inscribed, that means that we have 4-sided figures within a circle, inside a circle. And what it says is, if we have a quadrilateral ABCD and it's inside a circle, this is important, then its opposite angles are supplementary. And I want you to write down not congruent, not necessarily. Well, sometimes, very rarely, they'll be congruent, but usually they're not. So I want you to write down that opposite angles add up to equal 180 degrees. So for example, in number 9, find the angle measures of GHJK. That means I want 3 answers. I want what is angle G, I want what is angle H, I want what is angle J, and what is angle K. And what I know is that opposite angles are supplementary. So if you look, we don't know anything about H. We don't know anything. So we're going to have to use the fact that J and G are opposite of each other. They're across. So the first thing we're going to do is say 6b plus 20 plus that 3b plus 25 has to equal 180 degrees. So the first thing, set opposite angles equal to 180. And then solve for b. So we have a 6b and a 3b. That's 9b. And we have 20 plus 25, that's 45. Then I'm going to subtract, and I'm going to get 9b equals 135. And I'm going to divide, and I get, oh, 9. B equals 15. Then what I'm going to do is I'm going to go back and plug it into all these angles. So the third step is to plug in. So let's see. Let's say I plug it into this angle, angle G. Well, 3 times 15 is 45, plus 25, I think, is 70 degrees. All right, so we could go ahead and plug it into J, but we already know that they're opposite angles, so they have to add up to be 180. So if G is 170, that means J has to be 110, because 70 plus 110 equals 180. Now, the last thing we need to know, we don't know anything about H, so that means we have to do K first. So 15 times 10 is 150. 150 minus 69 is 81 degrees. So angle K equals 81 degrees. And how do we figure out what angle H is? Well, that's got to be 180 minus 81. So that would be, what, 99 degrees? And that's how you figure out what all the angles are. So I know 10 looks a little complicated because we have a fraction, but it is the same 3 steps. First, set the opposite angles equal to 180. Then solve for your variable. Then plug it in. Okay? All right. This exit question is a little tricky. I want to see if you know how to do this one. So this is the last thing you're going to do. You're going to do number 10, and then you're going to do the exit question, and then you are all done. Make sure for the quiz tomorrow you know what an inscribed angle is and what the difference is. What is the difference between a central angle and an inscribed angle? All right, enjoy.